Okay. So next one is carbon nanotube FET, CNT FET. So carbon nanotubes are very, very popular now. This is a recent technology which is very famous for the past 5 to 6 years. Okay. So making FETs made of carbon nanotube. Okay, so usually FET is made up of silicon or germanium, or if you have direct band gap, you are going to make them from gallium, arsenic, phosphorus, indium, aluminum. So all these metals you are going to use. But using carbon, they tried this and found that it is going to have a very good results. Okay, so carbon nanotube. So nano it indicates the size is going to be in the size of nanometer or 10 power minus 9. So it is made up of allotropes of carbon having diameter measuring the nanoscale. Nano is 10 power minus 9. So nano, you can say, what is the exact representation of nano? Nano is about 10,000 times smaller than a human hair. See, our hair is in the order of millimeters, right? So and that itself is very fragile. But if I make the size of the human hair 10,000 times smaller, then that becomes the size of your carbon nanotube. So nanotube means the dimensions will be in the order of nanometers and it is made up of carbon. CNT is unique. You may ask a question. Already our human hair itself is very flexible. If I make the carbon nanotube 10,000 times smaller than the human hair, will it be will it be even more fragile? If we touch itself, will it break? That is not the case. CNT is unique because the bonding between the atoms is very strong. Carbon atoms are going to bond very, very strong. So depending on the diameter of the nanotube, the intrinsic carrier concentration and band gap is going to vary. Okay, so the electrical property of semiconducting CNT, such as the mean free path, excellent carrier mobility, carrier transport for several hundred nanometers, and improved electrostatics have made it a suitable replacement for silicon at nanoscale. So when people started using silicon at nanometer dimension, they had lot of issues because fabricating silicon was very difficult and the mobility and other parameters were not up to the mark. But when they tried the same thing using carbon, manufacturing carbon nanotubes, then the properties such as mean free path, carrier mobility, carrier transport, and other things were found to be very good compared to silicon. So they started using carbon nanotube as a replacement for silicon at nanometers dimension. So by using a single wall CNT as a channel between the two electrodes, which work as a source and drain contacts of it, a CNT FET can be fabricated. So where is the CNT introduced into the FET? In the channel, I am going to use CNT, carbon nanotube. Okay, I mean, between the source and drain, you have a channel, right? So in that channel, I'm going to use carbon nanotube. So since the gate contact wraps all around the carbon nanotube, it has very good control on the carrier and allows for better electrostatics. Carbon is an insulator, and only when you change the characteristics, carbon becomes a semiconductor. So that is very good for me because I am able to control the parameters of carbon nanotube by applying a particular gate voltage. So